So now we're going to go into some problems. They disguise trig problems as in word problems. A tree casts a shadow of 12.4 meters. The angle of elevation of the sun is 52 degrees. And how tall is the tree? Alright, this represents my tree. Trees grow at a 90-degree angle. So in all of these, you're going to have something like a building or a tree, something that's 90 degrees from the ground. And a tree casts a shadow of 12.4 meters. So the shadow comes down. That means this side of the triangle is 12.4 meters. Now, angle of elevation. If you look straight ahead and you go up and angle up and look up from straight ahead, this is going to be an angle of elevation or inclination. The other way, though, is called an angle of depression or declination. So depending on what terms they use in your book or your teacher uses, it's either elevation or inclination, and then going down it's depression. So elevation means that from the ground up, that's our angle. And our angle here is going to be 52 degrees. So this is a Sohcahtoa problem. We have an angle, and we're trying to figure out how tall the tree is. So if I'm standing in the corner here, at theta, 52 degrees, I think, alright, I have opposite. I also have adjacent. That means I'm going to be using tangent of 52. The ratio is going to be opposite over adjacent, so that's x over 12.4. I multiply by 12.4 on both sides, and I get an answer, working it out at 15.9 with some rounding. So that tree is 15.9 meters tall. That's a tall tree. Okay, so that's one way that they can disguise a right triangle. Just remember, when in doubt, write it out, draw a picture. So the second question here is a little more involved. Johnny is 5 feet 9 inches and notices a flagpole has an angle of elevation 40 degrees. He is 12 feet away from the flagpole. How tall is the flagpole? So here's the flagpole. Flagpole is at a right angle. And then this represents Johnny. Now looking straight ahead, he notices the angle of elevation going up to the top of the flagpole is 40 degrees. He also knows he's 12 feet away, which means that it's 12 here as well. And this should be a right angle because these lines here are parallel. So we're trying to figure out the entire flagpole, but notice in this triangle here, this triangle we only have the ability to find x right there. So let's figure that out. That would be opposite, and this would be adjacent. And so we would use tangent of 40 degrees equals x over 12. So working that out, tangent of 40 times 12, I'm getting an answer of 10.1. Now that represents just this length right here, 10.1. And so on a lot of multiple choices, you would see 10.1 as an answer, but we might forget that there's a height here. And that height, Johnny is 5 feet 9 inches. Alright, so this is 5 and 9 twelfths. 9 twelfths because every 12 inches is a foot. So to find the total feet, you do 5 and 9 twelfths. Or you could do 5 plus 9 divided by 12. And that's 5.75 feet. That distance there is going to be the same as the remaining distance on the other side. 10.1 plus 5.75. The total height is going to be actually 15.85 or 15.9 depending on how you round. So we know that the flagpole is about almost 16 feet tall. So again, if you're stuck, draw a picture, label all the parts you do know, and try to find that right triangle.